The topic we're going to cover today is ions. Okay, so ions are atoms or groups of atoms with a positive or negative charge, meaning that they're atoms that have gained or lost electrons. That's how you become either positive charge, where you have more protons than your electrons because you lost electrons, or you end up being a negative charge where the atom gained electrons, so it has more negative electrons than protons. And in an atom, atoms are neutrally charged. They have equal number of protons and electrons. So if they gain or lose electrons, they're going to become ions. And they do this to become more stable. So if an atom ends up getting electrons, if it loses electrons to become more stable, we call that a cation that has a positive charge. So kind of a cute way to remember that cations are positively charged. Think about the word, cat, meow, and it has a pause, like cats have paws that they walk on. They have a positive charge. Cations have a positive charge. So it's just a cute way to remember that the cation is the positively charged ion. When you gain electrons or add electrons to your atom, you become an anion. So it has an overall negative charge, or the negative electrons outnumber the protons. They have an overall charge that's negative. So tell the difference between when you're looking at symbols, if you're working with an atom or an ion. Ions always have a plus or minus sign superscript with the number of electrons that it gained or lost. If you don't see a number, it means it gained or lost one. Okay, so here's sodium, the atom, sodium, the ion that lost an electron, so it has a positive 1 charge. Calcium, the atom, becomes stable, it loses 2 electrons, so it has, the ion is a plus 2 charge. Iodine, the atom, to become stable, it gains 1 electron, so this is the ion, iodide, negative 1 charge. Oxygen, to become stable, here's the atom. To become stable becomes the ion, and it gains 2 electrons to become stable. So it's oxide, the oxide ion. It has a negative 2 superscript as its symbol. Okay, so forming cations and ions, so just anions, just to kind of go over it again. Cation is formed when an atom loses 1 or more electrons, so it becomes more positive. So here, magnesium, the atom, to become stable, it has to gain 2 more electrons to have a full outer outer shell. So here's the cation plus the 2 electrons it lost. An anion is an atom that gains 1 or more electrons. So here is fluorine. It gains an electron to become more stable, so it becomes fluoride, the ion, and we show it with the symbol negative, no number, or 1 to show how, its ion symbol. All right, predicting ion charges. Okay, so in general, metals, so for example, in the last example, magnesium that we used, metals lose electrons to become stable. So it's easier for metals to lose electrons to become stable than to gain, because they have to lose less electrons than they would have to gain electrons to become stable. So they're trying to become like the noble gases that are closest to them, so it's easier for them to lose electrons to become like the same configuration as a noble gas. So metals are cations. Non-metals become stable, like fluorine in the last example, they gain electrons. So your nonmetals, the ones that are on the right side of the steps on the periodic table, they are anions. So in order to become like the same electron configuration as a noble gas, it's much easier for nonmetals to gain the few electrons, like 3 or less electrons, than it would be to like gain 5 or more electrons. So your nonmetals will gain electrons to become stable, so those will be your anions. All right, so let's get some practice here. Here, if you were looking at the isotope symbol for these ions, you can figure out how many protons, neutrons, electrons they each have. So for example here, this is potassium 39, the mass number 39, the atomic number 19. So based on those numbers, we know that the proton number is the same as the atomic number, so 19. Neutrons, again, is when you take the mass number and subtract the number of protons or the atomic number from it. So in this case, 39, the mass number, minus 19, so we're left with 20. So now for the electrons, we have to look at the atomic number and the symbol if there is one. So here we have 19 protons, and we have the ion symbol +1. So +1 charge means it has more protons than electrons because it's more positively charged, and it has a symbol +1 in essence. So this means it has one more proton than it does electrons because it lost an electron to become one more positively charged. So if it lost one electron, before when it was neutral, it was 19 protons, 19 electrons. It lost one electron to become one more positive charge. So that means it has 18 electrons. Okay, oxygen 16. Okay, so mass number 16, atomic number 8, ion symbol -2. Okay, so for proton number, same as the atomic number. So in this case, 8. Oxygen will always have 8 protons. This isotope of oxygen has 16 as its mass number. So to find the neutrons, we have to take the mass number 16 minus the 8 protons. So 16 minus 8 gives us 8 neutrons. Okay, now for the electrons. Okay, as an atom, oxygen would have 8 electrons since it has 8 protons. However, it became an ion, and here a -2 charge. So did it gain or lose electrons? So if it has a -2 charge, it means it has more of a negative charge, which means it gained electrons. So it's showing here that we gained 2 electrons. So we did have 8 electrons before because we had 8 protons, but we gained 2. So we have 2 more electrons than protons. So that means our electron number has to be, if you guessed 10, you are right. Okay, calcium 41. So calcium 41 has an ion symbol +2. Calcium always has the atomic number 20. So for protons, that means that we have 20 protons. For the neutrons, again, we have to take the mass number and subtract the protons from it. So 41 minus 20, so we get 21. Okay, so as calcium as an atom, it would have 20 protons, 20 electrons. But here we see the symbol +2. So +2, it's more positive. So did we gain electrons or lose electrons? Keeping in mind that electrons are negatively charged. So if we are positively charged, that means that you lost negative particles, you lost negative electrons, and it has a +2 here. So that's indicating that we lost 2 electrons, so we have 2 more protons and electrons, and that's why we have a +2 overall charge. So we have 20 protons. From this symbol, we know that we have 2 more protons than we do electrons. So that means that we would have, if you got 18 electrons, then you would be correct. Okay. All right, so one last kind of chance to learn here. Here you're going to need your periodic table to look at your proton atomic numbers. Okay. All right, so letter A here, 8 protons, 8 neutrons, 8 electrons. Okay, so proton number 8, well, that would be atomic number 8, which would be oxygen. We have 8 neutrons, so to get the mass number, we have to do protons plus neutrons. 8 plus 8 is 16. And then to figure out if we're an ion, we have 8 electrons and 8 protons. So we have the same number of positives as negatives, so we are an atom here. So your symbol would be 16 mass, 8 atomic number, and then oxygen. So no symbol plus or minus because we have the same number of protons and electrons. Okay, B, 17 protons. Okay, so look up number 17 on your periodic table. So that would be chlorine. Okay, so atomic number 17. The mass number is based again on your protons and neutrons. So here we have 17 protons and 20 neutrons. So to get the mass number, you have to add those two numbers together. So we would have 20 plus 17, which would give us 37. So now to figure out if we're an atom or an ion, protons 17, electrons is 17. So we have the same number of positives as negatives. So we have an overall neutral charge, no charge. So that means that we are chlorine the atom. So this would be the symbol, 37 mass number over 17 the atomic number, and then chlorine, no symbol plus or minus because we have no charge. All right, last one, 47 protons. So that's going to tell us our atomic number to figure out what elements or atom we're looking up. Okay, so number 47 on your periodic table is silver, Ag. We have neutrons is 60. So to figure out the mass number, 47 plus 60, so it would be 107. And then we have 46 electrons. So we figure out if we're an ion or not. So we have 47 positive protons, 46 negative electrons. Okay, so those are different. So we have a charge. Okay, so we have one more proton than electrons. So are we positively charged or negatively charged overall? So if you said positively charged, you would be correct. And we have one more proton than electrons, so that means we have a +1 charge or plus charge. So this would be your symbol, 107 over 47, the atomic number, and silver +1 charge. Okay. All right, last thing, you can label your periodic table. You're going to want these charges to help you remember when you're doing different problems. So your first column, 1A, in order to be stable, those elements will always lose an electron to become like the 8A noble gases. So this column always will be a +1 charge. Elements in the 2A column, they always lose 2 electrons to become stable, so those are a +2 charge. The 5A column, those here so again on the left hand side are your metals that like to lose electrons. Here we're going to get to our non-metals that like to gain electrons. So the 5A elements, they will gain 3 electrons to become stable. The 6A elements will gain 2 electrons to become stable. Like they're trying to get to become the noble gas configuration, like the 8A elements. And then the halogen 7A column, they will gain 1 electron to become stable. So they form -1 ions. So by losing or gaining electrons, atoms will have the same number of electrons as the nearest group 8A or your noble gas atom. That's the whole point. Atoms are trying to become stable like the 8A noble gases, so they're going to gain or lose electrons to do so. All right, that is it. Thank you.